Now, this is the second lecture on integration by partial fractions, and I have written down an example. An example that I want both me and you to look at. Now, this is what we have. They say to us we should compute the integral of x plus 14 divided by x plus 5, x plus 2 dx. This is what we should compute. And we should immediately ask ourselves, how do we compute that? This is the first question that we need to ask ourselves. How do we compute that? Right. I have written some few notes that might guide us into this problem so that we, at the end of the day, understand what is happening here. Now, the solution. Now, the first thing that we will do, we will try to decompose this. And when we decompose x plus 14, x plus 5, x plus 2, we will decompose that as follows. We will say, okay, this x plus 14, x plus 5, x plus 2, we will say this is equals to whatever we have, x plus 5 plus x plus 2. Now remember, let me take you through the notes. Now remember what we said. We said that if this is what we have, we will write each of what we have on the denominator as a what now? When we compute, we are simply separating the factors that we have on the denominator. We are separating them with addition, and for each factor, we write that as a fraction. That's what we said. We will take x plus 5, say this is x plus 5 divided by whatever we will assign any alphabet, looking very clearly whether we are working with a linear or an irreducible quadratic factor. Right, because this is a linear, we know that we are going to assign an alphabet, maybe A1, B1, C1, and so on. If we work with C, we will have C1 and C2. If A1 and A2. So we will look at the denominator. I can see that, okay, I have two factors, so I will split them with an addition. I will take the first factor and write it as a fraction, and I know that the degree of the denominator must be 1 more than the degree of the degree of the denominator must be 1 more than the degree of the numerator, or the degree of the numerator must be 1 less than the degree of the denominator. So this is exactly what we will do. This builds up on what we said in our first lecture. And then when I'm done saying that, the question is, how do I find the missing values? How do I find the missing values? Right. And then I wrote, there is no indication of what the numerators should be. As you can see that we have assigned a question mark for that. So there is work to be done in finding them. That is very true. If we let the numerators to be variables, we can use algebra to solve that. If we allow them to be alphabets, we can use algebra to do that. And that is, we want to find the constants a and b. That makes the equation below true for all x, except when x is 5 and minus 2. Because we know that when x is minus 5 and minus 2, this is unsolvable. you cannot have the denominator being equals to 0. And we know that from grade 8, grade 9, in our South African way of mathematics, this is not allowed. Even from grade 6 and grade 7. Right. And then, so now, how can we rewrite this? Remember, we have x plus 14, x plus 5, x plus 2. And I'm going to assign the alphabet. I will assign A, since I must find two different values, because I have different factors. So I will say A, x plus 5, and B, x plus 2. Or you can say A1 and A2. That is also fine. But I want to use different alphabets so that we clearly see what is happening here. And then we will have to solve for A and B by cross multiplication and equating the numerators, because those are one of the rules that we read. I think it was the last rule, number 5, where we said, okay, we will take our partial fraction and we will equate it to these linear factors that we have. So when we are here, we are saying we will apply cross multiplication. Okay, so how do I apply this cross multiplication? That is the first thing. Now, because this is an equation, I know how to deal with this. In order to get rid of the denominator, I'm going to multiply everything on the left and the right by the denominator. So I'm saying that I will say x plus 14, x plus 5, x plus 2, multiplied by x plus 5, x plus 2. This being equal, whatever I did on the left, I must also do on the right. X plus 5, x plus 5, x plus 2, multiplying this, plus writing that, multiplying by this. Okay, that's fine. So I know that this into this goes once, and this into this goes once. You have A, x plus 2. This into this goes once. You have B, x plus 5. This is pure basic algebra. Even a grade 8 student will understand purely what transpires there. And then when I am here now, I need to find the values of A and B. Now, that is fine. I think what I can do, I can remove the brackets by multiplication in here. So I can say AX plus A2, BX plus B5, and this is X plus 14. And now the question is, how do I solve for that? That should be the question. Now, this leaves us with the systems of the equations. Now, what are those systems of equations? Because I have my x plus 14 equals ax plus a2 plus bx plus b5. And then how do I solve this? The question is, how do I solve it? Now, let me just write this as x plus 14, ax plus 2a, bx plus 5b. This is exactly what I have. So, how do I solve for this? This is very, very important. How do I solve for this? Now, I want to take your attention to something. I want to rewrite this. X plus 14 equals ax plus bx plus 2a plus 5b. Just trying to group something that looks like the like terms. If you have watched my tutorial where I talked about complex numbers, you will know how to solve this. You will see that in here you will have a plus b equals 1 because there's a 1 there. You will say a plus b equals 1, and you will say 2a plus 5b equals 14. So this is that because it represents the constant, and this plus this is equals to that. This is my approach of complex numbers, and I'm doing the very same thing with this. So a plus b equals 1 and 2a plus 5b equals 14. And can I solve for this? Can I solve for this? Because I can say, okay, all right, how do I find a and how do I find b? Well, I can say, okay, all right, I can treat this. Let me show you. A plus b equals 1, 2a plus 5b equals 14. So I can use a method of elimination. Yes, I can use a method of elimination. I can say 2a minus a plus 5b minus b equals 14 minus 1. This minus this, there it is. This minus that, there it is. This minus this, there it is. 2a minus a is a. 5b minus b is 4b. 14 minus 1 is 13. I can do this. Okay? And then once I have done that, I can say, okay, since this is what I have, I can try and say, okay, my a, let me just come here. My a equals 13 minus 4b. I can have this. And I can substitute this on either this or this. And I can say that, okay, where I see a, 13 minus 4b, remember we are on this one, plus b equals 1. And I can say 13, what is minus 4b plus b? That is minus 3b equals 1. Take this to the other side, minus 3b, 1 minus 13, b being equals to minus 12 over minus 3, 3, 6, 9, 12, giving me b with a value of 4. Very, very important that we see that. Highly and highly important that we try to see that. Okay. And then now that I have b, I can simply find a. I can say a plus b equals 1. And I can say a plus 4 equals 1. A equals 1 minus 4. A equals minus 3. And I am done. And now I can say the integral of x plus 14 divided by x plus 5, x plus 2 dx. This is equal to the integral. My a, remember, my a is minus 3 divided by x plus 5 plus 4, which is the value of b, divided by x plus 2. This is what I have, dx. Okay, and this will be equal, we know how to integrate this. The integral of this is minus 3, the length of x plus 5, absolute value, plus 4, the length of the absolute value of x plus 2, plus c. And I'm done. And I am purely done. we are done with the first problem. And guys, this is just all what I had for tutorial 1 and 2. We will continue with some other tutorials, but I thank you for watching.